in this timer programming, okay, you will learn about the introductions of the timers, as well as the programming for the timer 0, timer 1, and timer 2. Okay, so as I mentioned earlier in the previous class, okay, for the timers, we have 3 timers, which is timer 0, timer 1, and timer 2. So you will need to know how to do the programming for all these timers here. And at the same time, we are going to do some counters. Okay, so let's look at the introduction of the timers. So in micro P, okay, we use a counter register in order to count an event or to generate a time delay. So this counter register is actually used to count an event. Okay, it can do 2 things here. Either you're going to count an event or you're going to generate the times delays. Okay, so to count an event, so what you need to do here is you need to connect the external event source to the clock pin of the register. Okay, so every time you're going to make use of your timer as to count a certain event, so what you need to do is you need to connect the external event source, okay, to your counter register. Okay, so whenever the event occurs externally, the content of the counter will be incremented. Okay, and then the next is to generate a time delay. So this counter register also can be used to generate a time delay, which is to generate a time delay. So what you need to do here is you need to connect the oscillator. Okay, wait. Okay, so what you need to do is you need to connect the oscillator to the clock pin of the counters. Okay, so this is how you're going to generate the delay. So when the oscillator sticks, the content of the counter is incremented. So this is a general view of the counters and timer in microcontroller. So this is the counter register. Okay, so this counter register in Atmega 32, this counter register is known as a TCNT. Okay, we have a register known as a TCNT, which is act as a counter register. So this counter register here is used to is used to count an event or to count a timer every time a certain event or a certain timer is incremented. Okay, so here, if you can see, this counter register is connected to this multiplexer. Okay, you have a multiplexer here. It is a 2-to-1 mux. Okay, so here from this multiplexer, you see here you have a what we call here, 2 input. Either it is oscillator or it is external source. Okay, so what happened here is if you choose as oscillator, okay, to fed into your counter register. So what happened here? You're going to use, okay, your timer to generate a time delay. Okay, if you choose external source, okay, as an input to your counter register, so what happened here? Okay, you make your timer to generate or to count a certain event. Okay, so this is what the timer all about. Okay, so the content of the counter register represent how many ticks have occurred from the time we have appeared the counter. Okay, so this is the basic background, okay, for the timer, which is you have counter register, and this counter register will be connected either to oscillator or external source. Okay, so for the timer, in order, okay, since we know that, okay, timer is used to count an event or to generate a timer, okay, so or to generate a time delay. So in order to generate a time delay, you have 2 methods. Okay, so the first method here, we call it as a, okay, so this is a compare mesh. right? So this one, the first method, we call it as a compare mesh or CTC, which is, okay, what you're going to do here is you need to clear the counter at the start of the time and wait until the counter reach a certain number. Okay, as I mentioned in the previous class, okay, for the timer, you have two methods for the timer in order to generate a certain delay. Okay, one by using the overflow method, and the second one you can use a CTC or compare mesh method. Okay, so for the compare mesh or the CTC method, what you need to do is you need to clear the counter at the beginning of your start time and wait until the counter reach a certain number. Okay, so earlier, okay, I already told you, okay, you have a water bottle. Okay, for the CTC, okay, what you need to do is, okay, so this water bottle is empty, and then to generate a delay by using a compare mesh, what you need to do is you need to set a water level. Okay, so this is the level that you're going to set in order to generate a certain delays here. Okay, so what happened here is, so you put a water inside of the water bottle, and when the water level here is, okay, reach to this level, the threshold level that you set earlier, so what happened here is you already generate your delay. So this is the delay generation by using the CTC mode or compare mesh mode. Okay, so this example here, okay, how to use the what we call to generate a delay, time delay by using the compare mesh or the first method here. So a microprocessor speed is 1 megahertz. Okay, given that the speed of your microprocessor is 1 megahertz, and the content of the counter register increment 1 per microsecond. So your counter register is increment, okay, 1 microsecond every ticks. Those, if you want to generate a time delay of 100 microseconds, what you're going to do is we should clear the counter and wait until it becomes hundreds. Okay, so you know that the speed of your microprocessor is 1 megahertz, and the content of the counter register increment 1 microsecond. So every tick it will increment 1 microsecond. So now you're going to generate 100 millisecond delay. So what happened here is, okay, so 100 millisecond delay equal to 100 times, okay, the count, the total number of the counter register need to count, multiply with 100 millisecond, then you get 100, total of 100 millisecond delay. So how to do that? So you need to set your level so that your level is 100. So first, what you need to do is, okay, your TCNT, which is your counter register, make sure that your counter register is empty, and this counter register will be incremented 1 microsecond for every ticks or for every clock pass. So what happened here is when it reached to 100 count or 100 ticks, so what happened? You already generate a 100 millisecond delay. So this is how the CTC mode or compare mesh mode works. Okay, and then in the micro P, there is a flag for each of the counters. So for the CTC, every time the level here, okay, the counter equal to the level that you set earlier, then what happen? The flag will be set. Okay, so this is by using the compare mesh. Then we have the what we call here the second method. We call it as a overflow method. Okay, so what this overflow do? Load the counter register and wait until the counter overflow and the flag is set. Okay, as I mentioned previously in the previous class, okay, how the overflows works. Okay, you have a water bottle. Okay, so now you're going to generate a delay. So what happened here is first you fill up your water bottle, okay, until a certain level, and then So what you're going to do here, so now you put a water inside your bottle, and when this level here is overflow, when the water from this bottle is overflow, so what happens? You already can generate the delay. So this is by using the overflow method. Okay, for examples here. Okay, again, a micropiece speed is 1 megahertz. Okay, you have a speed of microprocessor of 1 megahertz with an 8-bit counter register. Okay, the size of your counter register or water bottle here is 8-bit. Okay, if you want to generate 3 microseconds delay, okay, so the delay you're going to generate is 3 microseconds. So you know that since this is 1 megahertz microprocessor speed, so what happened here is, okay, every ticks, okay, or every clock pass or tick, okay, is equal to 1 microsecond. So in order to use what we call here uh, overflow method, so what you need to do is, since you're going to generate a 3 microseconds, so 3 microseconds equal to 3 ticks or 3 clock pass. So what you're going to do is, you need to load the counter register with FD. So this is your counter register, which is you set at FD, and then this counter register will increment it every time the clock pass is given to your microprocessor. So what happens here is, okay, for the first tick, the content will increment to FE, so you already generate 1 microsecond. And then the second tick, the content increment to FF. So this is another 1 microsecond, okay, which is now your water level is equal to this water bottle. So next, what happens is, when the third tick, the water inside of the bottle here will be overflow. Then what happens here, your content becomes 0, 0, and the flag is set. So you already generate a 3 microsecond delay after the overflow occurs. Okay, so this is by using the overflow method. Okay, so now you're going to see how to do the programming for timer 0, 1, and 2. Okay, so before that, okay, so let's look at the introduction on the programming of the timers 1, 0, and 2. Okay, so every timer need a clock pass to tick. So every time you need to use to generate a delay, so you need to have a clock pass. So this clock pass will increase your counter register. Okay, so the clock source can be either from internal clock source or external clock source. Okay, you have two clock source. Either is an internal clock source or external clock source, which is you given a clock from outside. Okay, so for the internal clock source, the frequency of the oscillator is fed into the timer as the time delay generation. So means that the internal clock source, you use your external speed, your oscillator, or your microprocessor speed. Okay, so your microprocessor speed will become your internal clock source. Okay, for the external clock source, a feed passes through one of the AVR pin as a counter. So means that you use another clock source from outside. Okay, so in Amiga 32, okay, there are 3 timers that you need to know, which is timer 0, timer 1, and timer 2. Okay, timer 0 and timer 2 both are 8-bit size, while timer 1 is 16-bit size. Okay, later we will see, okay, which one have advantage. Okay, is it a 16 bits or 8-bit timers? Okay, and then these timers, okay, timer 0, timer 1, timer 2 can be used as a timers, okay, which is to generate a delay, or can be used as a counter to count an event happening outside the microprocessor. Okay, so this is the introduction of the timer. Okay, then we look at the basic register of timers. Okay, there are few basic register of the timer that you need to know. Okay, so in Atmega 32, okay, there are total of 4 basic register that are associated with timer. So these 4 basic register you need to use in order to do timer programming. Okay, for the first one here is we call it as a TCNT register. Okay, and then we have the TCCR register. Okay, then you have your OCR register and TIFR register. Okay, so this is your timer. Okay, so this is your Omega 32. And so let's look at these figures here. Okay, so you have 3 timers: timer 0, timer 1, timer 2. Okay, timer 0 have TCNT. Okay, and then it also have the OCR, TCCCR, and then okay, this one here we call it as okay for this flags here. So this is your flags. TOV and OCF flag is inside of your TIFR register. So you need to know 4 basics register in order to do a timer. One is your TCNT, your counter register, and then TCCR. So this TCCR used to do a sum setting to your timers. Okay, which is you need to choose what are the mode that you're going to use. Okay, either is a compare mesh or overflow, and to choose the prescaler options. Okay, then you have a TIFR. So inside of the TIFR will have a flags. Okay, so this flag will be raised every time your timer or have been generated. Okay, so next we have a timer 2. Timer 2 also have a TCNT, TCCR, and then you have an OCR register as well as the TIFR. Similar to timer 1. Timer 1 also have a TCNT. Okay, you have a TCNT. Then it has a TCCR as well, OCR registers, and TIFR. So these 4 register, okay, you need to know in order to do timer programming. Okay, so let's look at what the TCNT do. Okay, so this TCNT register is actually your counter register. So TCNT is your counter register. So upon reset, the value inside of your TCNT will become 0. Okay, why? Because this TCNT register is actually inside of your IO registers. Okay, one of your IO register. So you already know that IO register consists of 64 registers. Okay, so this TCNT is one of the IO register. So this TCNT will count up with each pass. Okay, every time you give a pass here, okay, to your TCNT. So this is the TCNT. Okay, so this is a TCNT. So every time you give a pass or give a tick clock pass to this counter register, what happened? The value, okay, inside of this counter register will be incremented by 1. Okay, so this is your clock pass. Okay, so every time you give a clock pass and the counter register, okay, the TCNT will incremented by 1. Okay, so the content of the timers or counters can be accessed by loading a value to TCNT or read its value. Okay, you can access the TCNT, either you can read it or you can write a value to this TCNT. Okay, so this is for TCNT. Then let's look at the TCCR. Okay, TCCR register is used for setting the mode operation. Okay, so this is where you're going to do some settings. Okay, your timer. setting. All the setting will be done inside the TCCR registers. Okay, so there are, okay, so what are the mode that you can put inside, okay, that you can set in this TCCR? Okay, so you have a mode, timer mode. Either you're going to use it as a CTC mode or you're going to make it as a normal mode. Okay, so normal mode, it actually is a overflow method. Okay, CTC is a compare mesh method. Okay, so other than that, TCCR also used to specify the what we call here the prescale. Okay, later we'll see what is the use of this prescale. Okay, then you have the TOV and flags. Okay, whenever the timer overflow, and OCR flags. Okay, so this TOV flags and OCF flag is actually inside of your TIFR registers. Okay, so this one here inside TIFR registers. And then after that, we have the OCR register. So this OCR register is used to compare the content of the OCRN with the content of TCNT. So the OCR register only used when you use the CTC mode. Okay, why? Because in the CTC mode, you need to set the level. Okay, so this level here, you can set it on your OCR and register. Okay, so whenever your TCNT, which is your water bottle, okay, your TCNT is your water bottle. Okay, so what happened here? When TCNT equal to OCR, then the flag will set. Okay, so what flag will be set? The OCFN flag. Why? Because you use the CTC mode. Okay, so OCRN only valid, okay, only used when you use the CTC mode or compare mesh mode. Okay, if you use the overflow, okay, no need to initialize your OCR register. Okay, so here we see whenever the OCRN equal to TCNT value, then what happen? The OCF flag will be set. So this OCF and TOV flag is inside your TIFR register. Okay, and again, as I mentioned earlier, this timer register are located in your IO memory or in your IO registers. Those you can read or write to these registers here by using in and out instruction if you use an assembly language. Okay, so any question up until here? Ada soalan tak? Before we go more details on the programming parts. Okay, if no question, then we go to the timer zero programming in C. Okay, so before that, okay, we need to familiar with the registers that you're going to use in the timer zero programming. Okay, since this is a timer zero, so the counter register that you're going to use is, we call it as a TCNT 0. Okay, so timer 0 is a 8-bit in Atmega 32. Those, your counter register is 8-bit wide as well. Okay, so this is your TCNT 0 and it has a 8-bit data. Okay, so this TCNT 0 can count from 0, 0, 0, 0, 0 until 0, okay, FF. Okay, which is 0, 0, 0, 0, 0 until 1, 1, 1, 1, 1, 8 times, or 0 to FF, or 0 to 255 in decimal. Okay, so this is the maximum value. Okay, why? Because it's a 8-bit timer register. Okay, so what does TCNT0 do? So this TCNT0 is used as a counter register for timer 0. Okay, so that is the first part. Okay, you need to familiar with the counter register for the timer 0, which is TCNT 0. So the value, the value inside of the TCNT will incremented every clock pass. Okay, then we go to the TCCR, which is where you're going to do your timer settings. Okay, so since this is a timer 0, the TCCR that you need to use here is a TCCR 0. Okay, so TCCR 0 is an 8-bit register used for control of your timer 0. So this is your TCCR 0. Okay, TCCR stand for timer counter control register. Okay, so you have 8 bits, and then you have, each bit here have a certain function. So now I'm going to show you the bit that you need to focus, or you need to remember. Okay, one of the bit that you need to remember is bit 6 and bit 3. Okay, so this one you need to know. Okay, so bit 6 and bit 3 is actually to determine, your uh, the counter, the timer mode. Okay, so this one to determine the mode of your timer. Okay, because this mode of the timer, you have two actually. Okay, actually you have more than two. You have a 4 timer mode, but we only focus 4 timer mode. Sorry, 2 timer mode. Either normal mode, which is by using the overflow method, and CTC mode, which is by using the compare mesh method. Okay, so this is where you're going to set. Okay, if you put bit 6 0 and bit 3 0, so what happened here is you use a normal mode. Okay, so 0 0, you put to bit 6 and bit 3, what happened? You use a normal mode. Okay, if you put 0 1, then you use the CTC mode. Okay, so 0 1 here, you use a CTC mode, 0 0 normal mode. What about 1 0 1 1? Okay, so just ignore this one. Okay, because this one here by using the pulse width modulation. Okay, we're not going to cover this part. Okay, we are going to cover these two mode only, either normal mode or CTC mode. Okay, so this is the first. Okay, this is the bit that you need to do to know in order to choose the timer mode, and then that is the sec. Okay, then the bit that you need to know here is this last 3 bit. Okay, which is denoted as CS02 until CS00. So what this bit do? Okay, so this bit is actually to select your prescale. Okay, in which if you put 0000 means that you're going to stop your counter. Okay, so every time you're going to stop your counter, so make sure that you put 000 at these 3 bits. If you're going to 001, so what happened here? There is no prescaling. Okay, so what happened is you use the microprocessor your CPU speed. Okay, if your CPU speed is 1 megahertz, then you use that 1 megahertz as your clock pass. Okay, if you use a 010, so here this is the prescale. Okay, means that we divided the speed by 8 by 64 256 or by 1024. So this one we call it as a prescale. Okay, later we will see why we need to do this prescaling option. Okay, we need to use this prescaling option. Okay, for now, we just focus on these two. Okay, 0, 0, 0, 0 to stop your counter, and 0, 0, 0, 1 with no prescale, which is you use the same CPU speeds. Okay, and then when you put 110, so and 1111, this is where you're going to make your timer as a counter. Okay, if this setting here, okay, from 0001 until 101, this is where you're going to make your timer to generate the time delay. Okay, to generate a delay. Okay, if you're going to use your counter, sorry, to use your timer as a to act as a counter, so you need to set this value here, 110 or 111. Okay, so this is for the timer settings. Okay, what about other speed? Okay, other speed you can put 0. You can ignore and put them 0. Okay, and then okay, so this is the explanation about the this bit here, CS02 and CS00. So what happened? And WGM01 and WGM00, which is this bit here, bit 3 and bit 6. Okay, so let's look at the examples. Okay, now you're going to program, okay, timer 0 in normal mode, no prescaler. Okay, so again, so this is your TCCR. Okay, so TCCR0 have 8 bits. Okay, for the timer setting, you need to know bit 6 and bit 3. So this is for the timer settings. And for the prescale is bit 0 to bit 2. Okay, the rest of the bit you just ignore. Okay, so now what you're going to do here is you're going to, okay, to use a timer 0, okay, use a normal mode. Okay, what is a normal mode? Normal mode means that you're going to set bit 6 and bit 3 with 0, 0. So this is a normal mode. If you're going to use a CTC, so this bit here, you need to put 0 and 1. So this is CTC. Okay. So next is no prescale. Okay, so now what you're going to do here, so this is your TCCR0. Okay, since now in this example, okay, you're going to use a normal mode. So bit 6 is 0 and bit 3 also 0. So this one, now you know that this is a normal mode. And then no prescale. Okay, which is you will use your AVR crystal oscillator for the clock source. Okay, the same speed for your clock source, which is that is no prescaler. Okay, you use the same speed for your clock source. Okay, so how to choose a prescaler? Okay, to choose a prescaler, you can choose it at this bit here, bit 0, 1, and 2. Okay, in which when you put 0, 0, 0, 0 at this bit, what happens? So this one you're going to stop your counter. 0, 0, 1, it is no prescale. 0, 1, 0. So this is you're going to divide it by 8. Okay, you're going to use a prescaler with 8 prescale. And then after that, 0, 1, 1, this is 64. 1, 0, 0. So this is you're going to divide your your speed with 1 to 8. Okay, so you're going to use a 1 to 8 prescaler. Is it 1 to 8? Sorry, 256. Okay, not 1 to 8. It is 256. And when you put prescale of 101, so next what you're going to do is you're going to use 1024 prescale. Okay, so since now, okay, no prescaler, so what is the value that you're going to put here is 0, 0, 1. Okay, so what about the rest? Okay, the rest you just put 0. So how to do the settings? Okay, for timer 0 with a normal mode, no prescaler, how to do that in the C programming? Okay, you just simply write TCCR0 equal to 0B 0, 0, 0, 0 and 0, 0, 0, 1. Okay, so by looking at this here, okay, you know that, okay, so this is normal mode and with no prescale. Okay, so this is the coding, okay, in order to set, okay, do this setting. Timer 0, normal mode, no prescale. Okay, next. Find the timer clock frequency and its period for various AVR-based systems. With the following crystal frequency, assume that no prescale is used. Okay, so you're going to find out what are the period. Okay, so in this timer programming, okay, so you need to know a certain, what we call here, formula. Okay, one of the formula is, first formula that you need to know here is T equal to 1 over F. Okay, what is T? T is period. Okay, period equal to 1 over F, which is 1 divided by your frequency. So this is your T. And then the second, what we call here, the second formula that you need to remember is, here is delay equal to period times with your count. Okay, delay sama dengan period, okay, multiply with count. Okay, if you have 100 count and your period is 1 millisecond, so the delay that you're going to generate is 100 millisecond delay. Okay, so this T you can get from this formula, which is 1 over F, and count what is the numbers that you need. Okay, your counter register need to count in order to generate the certain delay. Okay, and then number 3 is TCNT equal to FF minus count plus 1. Okay, so this is the 3 formula that you need to know in order to do timer programming by using normal mode. Okay, later we'll see more detail on this part here. Okay, now we just going to focus on the equation 1. Okay, which is you're going given the frequency, okay, a speed of your CPUs, you're going to find out what is the periods. Okay, so now, okay, so given the clock frequency, okay, you have a clock frequency of 10 megahertz, 8 megahertz, and 1 megahertz. You're going to find out what are the periods. Okay, assume that no prescale is used. Okay, what is the meaning is by no prescale is used? Means that, okay, you use the same speed, okay, to get your period. Okay, if a prescale is used, then you need to divide your frequency with this value here first, and then after that, you can get your new period. Okay, for example here, okay, given that the CPU speed or your crystal frequency is 10 megahertz, what is the period? Okay, so F equal to 10 megahertz. T, by using this formula, equation 1, T equal to 1 over F, so you can 1 over 10 megahertz, you will get 0.1 microsecond. So what happened here is, okay, the clock pulse that you will generate is 1 microsecond every ticks, or every clock pulse, it will generate 0.1 microseconds. Okay, B 8 megahertz. So with a no prescaler, t equal to 1 over 8 megahertz, then you get 0.125 microsecond period. So means that every time you give a clock pulse, okay, it will generate 0.125 microseconds. And C, 1 megahertz, okay, given that the CPU frequency is 1 megahertz and with no prescale is used, so what happened here is t equal to 1 over 1 megahertz, then you will get 1 microsecond. How to get? Okay, any question up until here? Okay, if no question, then we go to the TIFR registers. Okay, so the TIFR stand for Timer Counter Interrupt Flag Register, contains the flag of different timer. Okay, so we already seen this TIFR register before. Okay, which is this TIFR register will contain the status of the flag for each of your timer. Okay, so this is for timer 0. This is for timer 2. And this part here for timer 1. So each of these timer here have two methods, either overflow or compare mesh. So TOV means that this is for the overflow method, timer for overflow, while OCF is for timer for compare mesh method. Right? So for the TOVO, which is timer 0 overflow, the flag is set when counter overflow, which is you're going from FF to 0 when the water is overflow from your water bottle. Then what happens? The TOV0 will set. Okay, so when the time roll over from FF to 00, TOV0 flag is set to 1 and it remains set until the software clears. Okay, so in order to reuse this timer, okay, because as I mentioned previously, okay, for the overflow method, it will generate the timer only once. Okay, if you're going to generate the timer periodically by using the overflow method, then what you need to do is you need to reset your timer settings. Okay, and then it will start counting again. Okay, or start generating a new delay. Okay, so this is a normal mode. Okay, so in a normal mode, okay, the content of the timer counter increments with each clock. Okay, so it will count up until it reach its max, which is FF. Okay, the maximum is FF. Why FF? Because timer 0 is 8-bit, so the maximum is FF. If you using a timer 1, it is a 16-bit, so the maximum of the counter register is FF. Okay, so when it's roll over from FF to 00, then what happens? The TOV0 will be set 1. Okay, so this is your TCNT and this is your time. Okay, so the TCNT will increase, okay, every clock pass. Okay, when it reach FF, what happened here? It will roll over back to 0. So when this happens, your TOV0 will equal to 1. Okay, so this will happen one time only. Okay, so this is not a periodic timer generation. If you're going to make it as a periodic delay generation, what you need to do is you need to do the setting again over here. Okay, so that your TOV0 equal to 0 and it will start counting again until your TC until 0 go to FF and it will roll over to 00, then TOV0 will raise once more. Okay, so this is for normal mode. Okay, So I think we stop here. And next week, okay, because tomorrow we're having a public holiday, so there is no class for tomorrow. Okay, and then we continue next week, and we start with the how to start timer zero by using normal mode method. Okay, any question, class?